Hello everyone, my name is Nilesh Raj from EC Department, Sri Venkateswara College of Engineering, Bangalore. My seminar topic is HDR image reconstruction using segmented image learning under the guidance of Professor Swapna CH. So, when a low dynamic range LDR image is converted to a high dynamic range image, an image that closely resembles the real world is produced without the use of expensive instruments. Recent advances in deep learning have enabled the creation of HDR photographs that are both realistic and intelligent. This study presents a deep learning method for segmenting the bright and the dark portion of an input LDR image and reconstruction an HDR image with similar dynamic range in the real world. To create the HDR image, the suggested multi-stage deep learning network brightens bright regions and dark parts, combining features with broader brightness range. The information about the missing overexposed and underexposed area is efficiently implemented by dividing the LDR image into bright and dark section, resulting in a natural HDR image with color and appearance that is similar reality. So here outline. So first one is history. Then second is what is HDR image construction. Then third is how it works. Why HDR construction use. Algorithm, framework, pros and cons, deep learning methods, experimental result, future scope and conclusion. So, significant image processing advancement in recent years have increased the demand of technologies that can produce image with real-world resolution. The most extensively utilized image quality enhancing technology is high dynamic range in comparison to the can operate beyond this typical camera sensor restriction to capture a large dynamic range. HDR provides photos with equivalent brightness to the range of human perception. As a result, most individuals have restricted access to HDR image. So, let us discuss about brief history of HDR, high dynamic range. In actually, HDR is so far older. This type of image comes from the very beginning of the art form, with some of the first example coming from Gustav Lee Gray, who was creating HDR image as early as the 1850s. Even the photographers knew that certain scenes were impossible to capture in one exposure. Gustav in particular vowed to maintain proper exposure of both the sky and the sea in his famous ocean photography. So, what is HDR image construction? So, when a low dynamic range LDR image is converted to a high dynamic range image, an image that closely resembles the real world is produced without the use of expensive construction. Significant image processing advancement in recent years have increased the demand for technology that can produce images with real-world resolutions. To produce HDR photo from the single layer photographs, inverse tone mapping ITM algorithm have been developed. Previously, ITM methods, on the other hand, have been insufficient for creating a function that is equivalent to the inverse camera response function and acquiring parameter that satisfies all picture situations in problem. LDR photos taken with several exposures. The photos are the stitched together to create HDR image. However, because multiple photos cannot be taken at the same time, so the ghost artifact that projects the flow of time appear when the fractured images are merged. Missing data areas can also be found outside of a specific exposure range. Convolution neural network CNN-based MEF approaches and CNN-based ITM method have been developed. The amount of saturated pixel in the HDR image is limited when compared to the total number of pixels. Weights are changed to reduce the global pixel value dissipates between the ground truth and interface image. Since image restriction commonly use loss function based on L1, L2 or mean square errors, as a result, the network weight and change as quick as they should be in order to recover the saturated pixel. The first one. The suggested method split the input image into bright and dark region that trains each separately. Overexposed portions are efficiently restored using bright regions, while underexposed sections are effectively restored using dark region. As a result, the proposed method can successfully restore all saturated pixels. The suggested picture segmentation marks creation approach is free of artifacts. When bright and dark sections are mixed, the suggested marks provides for smooth and clear image segmentation while eliminating boundaries plant artifacts. The multi-stage network structure that has been proposed increase the dynamic range and recover saturation pixel equality. Bright portions are brightened while dark regions are darkened to increase dynamic range. The features are then combined to create the final HDR image. HDR image HDR image HDR image provides photos with equivalent brightness to the range of human perception. As a result, most individuals have restricted access to HDR image. So let us on next slide. How HDR image construction works. So basically, these are some points. To produce HDR photos from single LDR photographs, inverse tone mapping (ITM) algorithm have been developed. Previously, ITM methods, on the other hand, have been insufficient for creating a function that is equivalent to the inverse camera response function (CRF), and acquiring parameters that satisfies all picture situation is problematic. To reconstruct HDR image from a single LDR image, CNN-based ITM algorithm have evolved this method map of LDR image to the HDR image through a CNN that acts as an inverse CRF. We present a method of recovering high dynamic range radiance map photographs taken with conventional imagery equipments. In our method, multiple photographs of the scenes are taken with different amount of exposure. Our algorithm uses these differently exposed photographs to recover the response function of the image process up to factors of scale using the assumptions of reciprocity. With the known response function, the algorithm can fuse the multiple photographs into a single high dynamic range radiance map whose pixel value are proportional to the true radiance value in the scene. We demonstrate our method or image acquired with the both photochemical and digital image processing. We discuss how this works as application in many areas of computer graphic involves digitized photographs include image-based modeling, image composing, and image processing. Lastly, we demonstrate a few applications of having high dynamic range radiation maps such as synthesizing realistic motion blur and simulating the response of the human visual system. We propose a technique for fusing a bracketed exposure sequence into a high quality image without converting to HDR first. Skipping the physical based HDR assembly step simplifies the equation pipeline. This avoids camera response curve calibration and is completely efficient. It also allows for including flash image in the sequence. Our technique blends multiple exposure guide by simple quality measures like saturation and contrast. This is done in multiple fashion to account for the brightness variation in the sequence. This result image quality is comparable to exciting tone mapping operation. High dynamic range HDR images are generally display technological are becoming increasingly popular in various applications. A standard and commonly used approach to obtain an HDR image is multiple exposure fusion technique, which consists of combining multiple images of the same scene varying exposure times. However, if this scene is not static during the sequence acquisition, moving objects manifest themselves as ghosting artifacts in the final HDR image. Detecting and removing ghost artifacts in an provide an up-to-date review of the recently proposed method of ghost-free HDR image and general mover classification and comparison of review method is reported to serve as a useful guide for the research of the topic. So, why HDR image construction used? So, here are some points. HDR image construction improve the quality factors like pixel, contrast, and the shade of the image. Second one, high dynamic range is the most widely used image quality enhancement technology. Substantial image processing advances over the past few years have increased the need for technology to produce images similar to real-world resolution. So these are the algorithm used for finding threshold. So here are the 22 types of algorithms. So we move to the next slide. Framework. These are the frameworks which input LDR image, then processing, then extract dark portion, extracting bright portion, deep learning, training, deep learning testing, predict image, output HDR image, performance metrics. These are the pros and cons of this topic. So here's we see some pros. The first one is higher dynamic range. Second one, it can enhance texture via micro contrast, local contrast. The third one, relatively used for someone who knows their cameras. There are application and even a Photoshop import feature that do the post-production for you. Here are some cons. Hellos, they look like a bit derivative now unless your tone is down. Doesn't suit figure, doesn't like skin which is tend to edges. Increases noise, reduce and often do not color accuracy. So development of high dynamic range HDR image has brought us to very of agree that larger chance in image display technology. Since the transition from the black and white to color television, novel capture and display hardware will soon enhance consumer to enjoy the HDR image experience in their own homes. The question remains, however, of the what to do with existing image and movies, which are instantly low dynamic range (LDR). Can this enormous volume of light also be displayed effectively on HDR displays? Deep learning methods. So here are some deep learning methods. Optimizer and loss functions. For the learning based method, we choose UNet as our architecture for its encoder decoder structure, which is greater candidate for construction tasks. The encoder consists of a several 2D convolution and max pooling blocks to condense the input image to representation space. The decoder systematically expand the representation with 2D upsampling and convolution blocks. So the next one is optimizer and loss functions, and the third optimizer and loss functions. So here are the experimental results. So we can see in the images like before image and the after image of the difference we can see that. So here the next before and after images. So future scope. If the suggestion as given in my paper will be implemented practically, HDR recreation from an erratic single uncovered LDR picture is a difficult assignment. To heartily take care of this issue, we have introduced a mixed dynamic reach autoencoder. This is to be assumed to develop in future and prepared considering the attributes of HDR picture in the model engineering, preparing information and improving strategy. So here's the conclusion. The quality and the flexibility of the HDR remarks have been shown through the various models as well as in emotional examination. One of the challenges in HDR image reconstruction is recovering saturated image regions. Quantization artifacts are less visible issue that can be mitigated using stabilized methods. However, we believe that deep learning can also be used to achieve bit depth expansion. So this is my presentation on this topic, and thank you.